Hello. Today we're going to solve a problem that combines basic knowledge of electrical circuits and the heat transfer. Let's read the question together. A figure shows a container with 360 grams of water and a circuit with 2 resistors and a battery. The temperature of water is 20 degrees centigrade. How long will it take for water to boil if the switch S is turned on? And the specific heat of the water is given as 4,190 joules per kilogram per centigrade. Well, let's tackle the circuit part of this problem first. So, a current that's generated from this battery is gonna go through this circuit in a following manner, right? So these two resistors are connected in series. What does this mean? This means that current that's going through this one and this resistor is exactly the same as the current going through the battery, right? Because current goes from here, we follow the wire, the same current goes through resistor 1, the same current goes through the resistor 2, and once the switch is closed, it's going to come back to the battery. What about the equivalent resistance of this network? Well, you have two resistors connected in series, so the total or equivalent resistance is going to be just sum of these resistors, which is 10 plus 20 equals to 30 ohms. Now we can find the total or net current going through this circuit, which is going to be the voltage of the battery divided by the total resistance, which is going to be 4 amps. So 4 amp of current going through the circuit through resistor 1 and through resistor 2. Well, as this current goes through these two resistors, it's gonna generate heat power, right? So power generated in resistor 1 is gonna be current that's going through this resistance 1 squared times that resistance R1. So 4 amps squared times 10, which is going to be 160 watts. Now, so this is the power, but how much heat is being generated? Well, to find the heat, the amount of heat energy, we just multiply the power by amount of the time that the circuit was on. So we know the power, which is 160 watts, but we do not know the time yet. So we just keep T here. And we assume that all of the heat that's being generated by this resistor goes into heating the water, right? So the amount of this heat that's being generated goes directly into heating the water. And when we supply a Q1 amount of heat, it increases the temperature of water by delta T, right? And we want to get to the boiling point. So we are sitting at 20 degrees and the boiling would be 100. So delta T, change in temperature, should be 80 degrees. Mass of the water is 360 grams or 0.36 kilograms. And specific heat of water is 4,190 joules per kilogram per centigrade. If we multiply all these numbers together, we get 120,672 joules of energy needed to heat the water from 20 degrees to 100 degrees or achieve a 80-degree temperature difference. Now, that means the circuit has to generate that amount of heat. So we know the amount of the heat generated by circuit is just 160 times the time the switch is on. So we set 160 T equals to 121,000 joules. And from here we can solve for T, which comes out to be 754 seconds, which is the same as 12 minutes and 34 seconds. And that's the answer and the solution for this problem.